Hi class, my name is Tiffany Molly, and I'm going to be discussing radon, radium, and its decay parts. The topics of explanation throughout my presentation are going to be what is radon, the history of radon, where it is found, the risk assessment, and then my conclusion. At normal room temperatures, radon is a tasteless, odorless, and colorless radioactive gas that results from the decay of uranium. Radon is a naturally occurring substance, and it also happens to be Earth's 84th most abundant element. As radon goes through the natural process of radioactive decay, it transitions through a series of elements known as radon decay products. As it does this, it emits three types of radiation, referred to as alpha, beta, and gamma. It is the alpha particle that has the potential to do the most damage to human tissue, despite its relatively short half-life of only 4 days. Radon was discovered by the English physicist Ernest Rutherford in 1899. The discovery is also credited to German physicist Friedrich Ernst Dorn in 1900. Specifically, Rutherford was awarded the discovery of radon's alpha radiation, whereas Dorn was credited with his notation that radon emitted a gas. Originally named niton after the Latin word for shining, radon was given its current name in 1923. Radium has been used to make luminous paints for the faces of wristwatches, clocks, and aircraft dials, but has largely been replaced by cobalt, a significantly less dangerous radioactive source. Radon is also used in very small doses to treat some types of cancer. Radon is found naturally in certain types of bedrock, commonly shale and granite. Radon forms deep beneath the Earth's surface and travels up through the soil, often exiting through open ground and diffusing into the atmosphere. As a gas, radon can also dissolve in groundwater and enter homes in rural areas through a well water supply. Radon can decay into longer-living, solid radioactive elements, which can collect in dust particles and then be inhaled. As you see in the picture to the left, this is the process of radon and radium into your home. Starting with fractured bedrock, which would be your shale or your granite, it can then go into soil or groundwater. From there, it can either go into a well water supply if you're in a rural area, or cracks in the foundation of your home. This slide shows the general areas that have low, moderate, and high exposure to radon and radium. For California, as you can see, we typically range between low and moderate. This is because of the type of soil and the type of weather we have here. Radon and its decay products are known as human carcinogens. Repeated exposure can result in both physical and chemical damage to cellular DNA. Radon exposure is the second leading cause of lung cancer in North America, preceded only by cigarette smoking. Lung cancer is the deadliest of all cancers for both men and women, and has a mortality rate of 84%. It is estimated that 10 to 15% of those deaths can be attributed to radon exposure. Radon only has chronic health effects, and exposure has little to no warning signs. Radon's radioactive gas particles get trapped in your lungs when you breathe. This may lead to chronic lung diseases such as emphysema, pneumonia, and pulmonary fibrosis. Most scientists agree that the risk of death for radon is approximately 1 in 100. The EPA and the Surgeon General's office have estimated that as many as 20,000 lung cancer deaths are caused each year by radon. Radon concentrations can vary from location to location. Even homes right next door to each other can have very different radon concentrations. How easily radon reaches the surface depends upon the soil's permeability. Moist clay soils are the most difficult to pass through, and dry sand is the easiest. Since gas condenses at lower temperatures, radon levels in soil are higher when it's cold outside. Normally, radon levels are highest closest to the source, so concentrations tend to be the most pronounced in the lowest floor of a home, like a basement. Risk from radon occurs from inhalation. Radon is retained in the lungs, allowing alpha decays to deliver a radiation dosage. Some studies show that women are twice as likely as men to have radon-induced lung cancer, a circumstance that may be the result of the domestic role that women play in some family situations. Risk of lung cancer in children resulting from exposure to radon may be almost twice as high as the risk of adults exposed to the exact same amount of radon. This is believed to be due to a child's different lung shape, size, and breathing rates. The Environmental Protection Agency has deemed January as National Radon Action Month. Each year during this time, they ask homeowners to test for radon in their homes and offer services for any problems that they may find. Radon testing is quite simple and can be done yourself, or a professional can be hired. Consumer Reports published a review of radon test kits in 2009 and found that long-term test kits were found to be more accurate than short-term test kits. Long-term test kits are done over 90 days, whereas short-term is only over 48 hours. If your home is found to have a radon level of 4 or higher, it's time to take some action. A radon mitigation contractor will be able to tell you what kind of radon control system will be the most effective for you, based upon where you live and what kind of foundation you have. Sub-slab depressurization is one of the most effective methods of lowering high radon levels in many homes. It works by lowering air pressure in the soil below the home, preventing radon gas from seeping into the house. In conclusion, radon is a colorless, odorless, and tasteless radioactive gas. It occurs naturally in the Earth's surface. It can be absorbed through soil, cracks in foundation, or a home's water supply. Long-term exposure to radon and its decay particles can cause lung diseases such as cancer, emphysema, pneumonia, and pulmonary fibrosis. Check your home annually for potential radon exposure if you don't already have radon sensors in place. This concludes my presentation on radon, radium, and its decay particles. Thank you so much.